So, this was me taking your crossword times, and I created a dot plot of them. Isn't this lovely?
It looks pretty good.
Thank you. Thank you. Do you guys see anything in the dot plot? Anything else?
Most people fell within the 2-minute to 4-minute range.
Oh, if I were to say that there are more dots from 2, and I'm going to say probably from 2 to, I don't know, 4 1/4. Would that be good? Like this is a huge chunk of the points, for sure. And if we drew a histogram, this would end up kind of being, it would kind of have, I'm going to call it mound shaped. It would have had like a mound right there in that region. Okay. All right. What else do you guys see? Yeah.
Nobody took under a minute.
Nobody took under a minute? No one took more than 7 minutes? Okay. All right. I have a challenge. I would like you to draw in 3 lines. They're going to be vertical lines. You can put them wherever you want. However, they need to have the same amount of points on each side of the line. So in other words, 3 vertical lines would cut the graph into 4 sections. 1, 2, 3, 4. Where could we draw those lines so that each of those sections has the same amount of points or pretty darn close to the same amount of points? You already did it. By the way, there are 16 in there, if that's helpful. Thoughts? Hopefully we have one like roughly here. And then, oh boy, here, kind of. And then here. Does that feel okay? 4 points in each section. And then I'm just going to draw on these kind of outer boundary lines. And like throwing those in, does it say anything to us? I see something kind of crazy there. But maybe I'm the only one.
Lines are closer and some are farther.
They're not equally spread apart, right? You know what else I see? This distance looks really, really big comparatively to these ones. But these ones look pretty darn close to each other. We okay with this idea? And why is this distance bigger?
Fewer people.
So that's not, no, because this has 4, this has 4, this is 4, this is 4. They all have the same amount of people, right?
It took a longer time.
There's more like variation in this chunk of the graph, yeah? Okay, so as the times got bigger and bigger and bigger, it became less and less predictable for the folks that took longer and longer and longer in terms of how long it would take them. Is this okay? All right. So we just approximated something called the 5-number summary. Okay? The reason I call it the 5-number summary is we in fact have 1, 2, 3, 4, 5 numbers that we describe with our 5-number summary. So the first one we have is called the minimum. It's the lowest of all the values. Given that we have the raw data up there, guys, what is the minimum?
1 minute.
I bet it's this one. The 1.08. Everybody good? So my minimum is 1.08. Okay. What about this line?
Is that the first quartile?
We call that, you know what? You're right. I'm doing this in the wrong order. I'm definitely doing this in the wrong order. Okay. How about this one? That's the maximum point, the highest number. The minimum and the maximum usually we do okay with. Okay? And it is in fact 7. Cool. What's this one called?
Median.
It's called the median. It's the halfway point, yeah? Now this one's a little bit more challenging for us to know what it is. So theoretically, to find these values, we need to, put these in increasing order. Okay? Now, I'm good with saying that my smallest one is 1.08. What's the next one up?
1.24.
1.55.
2.4. 2.45. 3.2. No, 3.11. And 3.2. 3.45. 3.49. 4. 4.26. 5.66. 6.75.
And then what I'm going to do is use those exact same divider lines that we just did, like every 4 points, to kind of help us see this a little bit better. Am I missing some?
There's only 14 of those numbers written above the plot graph, and 16 dots on the line.
Of course. I couldn't just copy and paste. I had to look at the numbers and go back and forth and back and forth. Let's see if I can't figure out which ones we're missing here.
It might be the one that's directly on the one. Oh, this one's in two.
I bet that's the 1.08.
This one's after two as well.
I'm sorry?
The one that's directly next to two.
The one that there's a 207, is that up there? Was it that would be 2.11? Is that there? Okay, so there's a 2.11 right there. And then I bet it's the top two that, because I was scrolling. So then go ahead and add a 3.89. And that would be this one right here, I think. So that would make sense. Sorry about that, y'all. All right, so now when I divide those lines in, it would be here, here, here. So this, the median, which we said was this line right here, is in between 3.2 and 3.45. So how do I figure out what number is exactly in between 3.2 and 3.45?
Add both of them, divide by 2.
Add them together and divide by 2. And that's how we find our median. So 3.325. 3.325. I think, is that right? All right, and then, so how do I describe where, how do I describe where this line is? Well, that's kind of in between the 2.11 and the 2.4, yeah? We call this one Q1. It stands for first quartile, okay? And the idea is it is the marker for the first quarter of our points, 1/4, right? We divided it into 4 equal groups, okay? So to do it, we just find the median. So we look at that, to find it, we essentially find the median of just that first half of the data. So I'm going to do 2.11 plus 2.4 divided by 2. And likewise, the third quartile marks the first 3/4 of our data. So, and we find that one, again, since it's in between 2 points, do 4 plus 4.26 divided by 2. I get, I think, 4.13.
Yeah.
All right. Now, one of the things I'm going to expect you to do, more so than calculating these numbers, because I'm going to show you eventually how the calculator does everything, because it's pretty sweet. I care much more that you know what these values mean in terms of the big picture of things. And really what they do is they describe relative location of things. Okay, so the minimum, we can use that to say the fast, in this case, that would be the fastest crossword time. And the maximum would be the longest crossword time. Those ones are usually not too bad for kids to interpret, okay? All right. Now, the quartiles and the median, we typically use percentages, okay? So that when we look at this, are you guys cool with me saying that 25% of you were in that range, 4 out of the 16? Does that make sense? So we're going to say 25% of FST students did the crossword in 2.745 minutes or less. And likewise, the median divided you guys up into half and half, right? So what percent was smaller than the median? Mm-hmm. And we always, not always, but we pretty much want you guys to focus on that time or less, the left-hand side of that point. And it's kind of laying some groundwork for some stuff that's going to come later. What percent are smaller than Q3? 75. So you would say 75%. All right. Now, we're going to care about essentially two different things within a group of numbers, like this set of data that we're trying to analyze. One, we want to approximate where the middle is. When we said, oh, it looks like most people are kind of between 2 and 4, that's approximating the middle. The other thing we want to kind of figure out is how spread out stuff is. In other words, like, how predictable are your crossword times? When you look at this graph, do you think your crossword times are super predictable, not predictable at all? What do you think? Fairly predictable? And what about the graph tells you that?
The fact that they're mostly found within the middle two.
We have this chunk kind of like where there's a lot of points, okay? What about these ones? Are they like super weird points? Are they super high? Is the one super low? It's kind of hard to tell right now, isn't it? Okay, so we need to use statistical tools to help us decide what is so far away that it might make us question what was going on and all that kind of stuff. So we have two types of statistical tools that we're going to work with for now. Measures of center that are going to include the mean and the median, and then measures of what we call variability, how spread out the stuff is. And the first measure of variability I'm going to teach you guys is the IQR. That IQR stands for interquartile range. And we calculate it by doing Q3 minus Q1. And in this case, that would be doing 4.13 minus 2.745. I would love somebody to check that arithmetic. Does it seem about right? 1385? Thank you. And that essentially just told us that this distance is equal to 1.385. Okay. All right, let's talk about the word outlier.
I have a question.
Yeah.
When you say that distance is 1.385, like this into a question. How is that distance, that number, because it's, like, we're not measuring it. What unit of measurement is,
Minutes?
so that's just the average minute time between those?
No. So, Mia, here's 2, here's 5. Yeah? And if I say 5 minus 2, that answer is 3. And if I asked you what is this distance, you would say?
See?
Okay, we good? So like subtraction gives us the distance between two numbers, and those are the two numbers we subtracted.
I didn't realize that's what you were talking about.
Is everybody okay? And now it's worth noting that this isn't really just 1.385, it is 1.385 minutes, and what that really means is that the middle 50% of students had times within 1.385 minutes of each other. And to me, that's actually fairly, that's not very spread out when you think about, 1.35 minutes is or 385 minutes is roughly a minute and 25 seconds. That's not that long. Okay. So the reason we care about these things is sometimes we have to decide, are there outliers within a distribution? Now, how many of you guys have heard the phrase outlier before? Okay. And if I asked you, just in your understanding of it, what is an outlier? What would you say?
A very randomly far out point.
Okay, so you say a randomly far out point?
Not randomly, just a very out there point.
A very out there point. Okay.
It's like a point that's like on its own, nothing's around it.
Okay. Go ahead.
Like it's separated from the other data, it doesn't make sense compared to the rest of the data.
Okay. All of those kind of are decent definitions of an outlier. Okay, in reality, an outlier is a point that is far away from the other points. Okay, do we have any that you think might be outliers in this distribution? Yeah?
Can the first one be an outlier?
Could the first one be can you have a low outlier?
Yeah.
Yeah,
Alright.
it absolutely could be. You could have a really, really low time, for sure. Okay, yeah.
So 1.08 and 7. They're both outliers?
What do you guys think?
No.
If we use the, I'm going to kind of pick on Walter's definition because it does have a there's something that he said that I like a really lot, okay? Given all the points, does this one feel weird to you? Just because it's low, it doesn't feel weird, right? And in fact, maybe the 7 does. Maybe the 6.75 does, right? And there was what Walter said was that it was a far out point. And I don't think he means surfer dude far out. I don't think. That's far out, man.
Oh, neither confirm nor deny.
Okay, that's fair enough. So, in reality, when we talk about a far out point, are we cool with calling it one that has a lot of distance? It's about distance, right? It's about the ones whose distance from the, other points, which is already starting to feel a little bit icky, because, this point isn't that far from this one. Maybe not that far from this one, but definitely far from these ones. Do you guys see what I'm saying here? It feels a little icky to just say far from the other points.
Far from the majority of points.
Okay. Go ahead.
I think that it's 5.66 because it has the most distance between the other points.
Oh, so you're saying because 5.66 is the one that actually feels the most isolated.
Yeah.
Okay. Okay. Can you have more than one?
Yeah.
God, this is hard.
Like if you had a point 125 second and then an 8 minute, those would be outliers.
Yeah.
To
what Walter said, if it is like the majority of the points, if that's how you want to define it, then it would just make the last three, I guess, outliers. So I would say that there can be several.
There definitely can be several. There can be several. For instance, is there an outlier in age in this room right now? Who is it?
You?
No, guys, I'm like 17. But what if the entire math department came in here? Would I still be an outlier in age? Probably. 'Cause all four of us would be, wouldn't we? We're still significantly far away from the rest of you. You guys okay with this?
What?
If the entire math department came and sat in this room right now, all three of us, well, because Mrs. Downer's not here today, but if Richards and Lombo came in here and we're all sitting in here, we would definitely still be outliers. Because if you looked at all the ages, you would see a whole bunch here and then a few spread out at the top. And it would be way spread out at the top. You know what I'm saying? Yeah.
If there's an equal amount of teachers to students that came in, then
Oh, that would be a different
there'd be
situation.
no outliers.
That would be correct. If all the teaching staff came in here, we had as many teachers as students, I don't know, Mr. Richards might still be an outlier. Mr. Wheeland would definitely be an outlier, right? For a long, I mean, he's been retired for at least 8 years.
What? He's retired but working.
Yeah.
Because he doesn't have an educational job.
He's a sub.
He just kind of shows
But
up.
I mean, Mr. Rummer started working here when Mr. Wheeland retired. So, like, he used to have the same job that Mr. Rummer has. And then he retired. This is very crazy. Okay, so are we ready to have a formal definition of how do we decide if something is an outlier or not? Okay, it goes like this. An outlier is more than 1.5 IQRs from either Q1 or Q3. Okay. Remember we talked about that IQR being the distance between those two things? And remember we're talking, like, we said, hey, my IQR is this distance right here, right? And we're describing this outlier as being an outlier if it's too far away being a measure of distance. So how do we decide what is too far away? 1.5 IQRs. But it's not 1.5 IQRs from here, it's 1.5 IQRs from either here or here. So from the quartiles. So to decide do we have any low outliers, that would be too far away from this point, yes? What was this number again?
2.745.
It was 2.745, that Q1, right? So what we're going to do is we're going to do Q1 minus 1.5 times the IQR. So if I do that here, that's going to be that 2.745 minus 1.5 times 1.385. And at this point, guys, you guys need to do this. We're getting beyond Ms. Meister's mental math capabilities.
I believe in you.
There's no question that is beyond my mental math capabilities.
You got you. You're looking good. You do it.
I could come close, I think.
Try. Yeah, try it.
2.604.
As the 1.5 times 1.
Mm-hmm.
Oh,
For the whole thing. For the
the
whole thing.
whole thing. I said 0.6.
Oh, 0.6.
Yeah.
0. So it was 0.
0.6675.
Now, this doesn't tell me any of our values. This just tells me how low it would need to be in order to be an outlier. Do we have any values that were lower than 0.6675?
No.
Okay, so do we have any low outliers?
No.
All right. Now, if it's a high outlier, which is where we kind of expect to see something, right? It's too far above Q3. So instead of doing Q1 minus 1.5 IQRs, I'm going to do Q3 plus 1.5 times the IQR. So in this case, that would be 4.13 plus 1.5 times 1.385. Do we see why on one side it's minus because it's lower than that value, and then the other side is plus because it's got to be higher than that value? 6, a little over 6 is what I'm guessing. Like 6.05 is my guess. How close am I?
6.2075.
Ooh, that's bad for me. I need to be doing better than this. So do we have any outliers? Because that 6.0275, that's like right here. Do we have any, both of these points are above that, right? So the not the 5.66, the 6.75 and the 7 are high outliers. How do you guys feel about 5-number summary and deciding about outliers?
That's too much writing.
Oh, you think that's too much writing?
Well, you should have said that. You should not have said
It's too colorful. Colorful's cool,
that. Like, it's,
Wow, why didn't you box plots on this? Do I do it tomorrow? Okay. Oh, man. No, I think it's going to work out fine.
Okay. So, put this away is what you're saying?
That's not what I was saying.
Oh.
Yeah.
Put it
That was like not what I was saying at all. I think we could do this box plot portion and then, yeah. We'll come back and we'll look at those other examples tomorrow, I think, is how that's going to work, okay? Do you guys know, have you heard of a box plot before? It might have been called a box and whisker plot.
Yeah.
Have you heard of a box and whisker plot before?
partially.
It was on that test you done took, like the ACT? ACT, it was on the ACT?
Maybe not. I'm not the standard.
You definitely did them in like, I don't know, 6th or 7th grade?
I think they were just like
What?
the 2 extra variables that we didn't add.
Yeah, we probably should. I mean, yes and no, because we're using the 5-number summary that we already found. All right. So guys, we said the min was 1.08. Q1 was like 2.875. 2 and some change. What was Q1? Can someone turn back and look for me?
2.745.
And then the median was 4.125? No. At this point, I'm confusing all my different data sets. I've got like
3.325.
3.325. Q3 was
4.13.
4.13. And then the max was 7. Cool. And then we had outliers at
6.75 and 7.
perfect. All right. Box plot is very similar to what we just drew when we drew in our dividing lines, okay? So to make a box plot, you're going to start with an axis. My lowest point on this is a 1. My highest point on this is a 7. So my axis is going to go from 1 to 7. Okay. My min. So a box plot has essentially 5 numbers to it. You have, this one's going to be your minimum. This line is going to be your Q1, your median, your Q3, and then your max. It is essentially a graph of that 5-number sum we just found. Okay? So what I'm going to do is make a point at 1.08 since that was my minimum. Then I'm going to do the 3 lines for the Q1, the median, and Q3. So 2.745, 3.3, 4.13. I can connect those. I'm going to make a point at 7, but I'm not connecting to that point. I'm going to make a point at 6.75, and I'm not going to connect to that point. I'm going to make a point at the 5.66 because that was the next highest point, and I'm only connecting to that point. In other words, we don't connect to outliers, but we still graph them. So I can look at this box plot right away and say, oh, there were 2 outliers that were really high, and then everything else looks pretty darn close to each other. Okay? I probably should put the word crossword times there and so on and so forth. How are we doing, okay? Is it making sense? We'll practice this some more tomorrow.